Hello everyone, our next concept is supernode analysis. Supernode analysis means in between two nodes if there exists a voltage source. Voltage source means either dependent source or independent source. If there exists a voltage source between two nodes, then we need to apply supernode analysis. Okay, for suppose if these two nodes are V1, V2, and if there exists a independent voltage source, say 2 volts, this is supernode technique. That means we need to apply supernode technique. For suppose there exists a dependent source. There exists a dependent source. In this case also we need to apply supernode technique. For suppose if there exists a independent voltage source parallel to suppose a resistance, let it be 2 volts. Here also we need to apply supernode analysis because in between two nodes there exists a independent voltage source. For suppose if there exists a dependent voltage source and in parallel with there is a resistance, let it be 4 ohm and say it is 2 volts, V1, V2. Here also we need to apply supernode technique because in between two nodes there is a dependent voltage source. In these 4 cases we need to apply supernode technique. For suppose if there is a resistance in series with voltage source and this branch is in between two nodes, so here we should not apply supernode technique because here there is a resistance. So there is no need to apply supernode technique here. We can solve directly by using nodal analysis technique. Whenever you want to solve any circuit by using supernode analysis, first open the dependent source or independent source, then write the node equations for all the remaining nodes, and then finally apply KVL for supernode, then solve the linear equations. Then you will get unknown variables. Here we can solve this supernode by using 3 techniques, that is for nodal analysis KCL plus Ohm's law. For supernode analysis we get extra KVL. Okay, these three techniques are used for supernode analysis. Now let us solve some problems on this technique. In that first question is find V1 and V2 in the following circuit. This is the given circuit. Okay, in between here these two nodes, in between these two nodes there exists a independent source, 8 volts independent source. So we need to apply supernode technique. So first open the independent source. So if you open the independent source, the circuit becomes like this. If you open the independent source, circuit becomes like this. Now write the node equation for V1 and V2 combinedly. Okay, write the node equation for V1 and V2 combinedly. So for V1, what is the node equation? This current is coming towards to the node, so taking it as negative plus this is V1 by 4 plus, now for V2 this is V2 by 6, for this branch V2 by 6, and this current is coming towards to the node, so it is minus 7 is equal to 0. Take LCM, this is minus 60 plus 3V1 plus 2V2 minus 84 is equal to 0. 3V1 plus 2V2 is equal to 144. Let it be equation 1. Now apply KVL for this node, these two nodes. Apply KVL for these two nodes. So the circuit becomes like this. So this is V1, this is plus minus 8 volts, this is plus minus, this is V2. So if you apply KVL for this loop, you will get V1 is equal to 8 plus V2. Okay, so this is positive, this positive are, so this negative, this positive is connected, but this positive is connected to this positive. So V1 is equal to 8, or you can write minus V1 plus 8 plus V2 is equal to 0. You can get same answer. From this you can write V1 minus V2 is equal to 8. Equation 2. Solve equation 1 and 2. You will get V1 is equal to 32 volts and V2 is equal to 24 volts. Same circuit you can solve by using mesh analysis. Okay, I will show how it will solve by mesh analysis. Okay, here we have 3 loops. This is first loop, second loop, third loop. In this loop the current is 5 amps because this branch current indicates this loop current. So this is 5 amps, and here we don't know the current, so let it be clockwise direction and take it is I1, let it be loop A. And here this branch current indicates this loop current, so this is 7 amps. Now write the mesh equation for loop A. So first consider, whenever you want to apply mesh analysis, sources is equal to passive element. So here we have only one source within this loop, so the current is entered to the positive terminal. Whenever current is entered to the positive terminal in mesh analysis, take it as negative. Minus 8 is equal to, sources are completed. So now coming to passive elements, here it is 6 into this current is coming top to bottom, and this current is also coming top to bottom. Both currents are in same direction, so I1 plus 7. And coming to this, here it is bottom to top, but this is top to bottom, so plus 4 into I1 minus 5. So by solving this equation you will get I1 is equal to minus 3 amps. Now I want to find out V1. This is V1, this is V2. So V1 is, this is plus, this is minus, this is plus, this is minus, means current should be enter here. Current should be enter here. So what is the current now? So current in the I4 ohm is equal to, this current is flowing in the same direction, so it is 5, but here this current is opposite to the this direction, so it is minus I1, that is equal to 5 minus I1 is minus 3, so it is 8 amps. So I4 ohm is equal to 8 amps. So V1 is equal to I4 ohm into R. This is 8 into 4, you will get 32 volts. Now coming to here, so I6 ohm. So what is the current? This is same direction to the I6. Here also it is same direction to the I6. So what is I6 ohm? I6 ohm is equal to I1 plus 7, that is minus 3 plus 7 is equal to 4 amps. So V2 is 6 into I6 ohm. 6 into 4 is equal to 24 volts. So in the both the cases we got same answer, that is 24 volts. V2 is 24 volts, V1 is 32 volts. Here also V1 is 32 volts, V2 is 24 volts. So whatever may be the given circuit, first decide which technique is suitable for the given problem. That means it should give accurate result in less time. It gives accurate result in less time. So first you choose suitable technique for given circuit. Next question, in the following circuit find V delta and V naught by using nodal analysis. Okay, this is the given circuit. Here the voltage across 4 ohm resistor is V delta. That means the node voltage here it is V delta. Okay, let it be reference node. So it is V delta. The voltage across this 40 ohm is V naught. That means these two are connected in parallel. So it is V naught. Now see here, previously we discussed if we want to apply nodal analysis technique to any circuit in parallel to independent voltage source, is there any element, that means either it is a resistance or independent current source, we can neglect it. Here this node voltage is 20 volts, so we can neglect this 66 ohm resistance. So now write the node equation for V0 and V0. Here for these two nodes, that means in between these two nodes there exists a dependent voltage source, so we need to apply here super node technique. Write the node equation for V delta, that is super node technique or super node analysis. So first open the dependent source. Open the dependent source means just forget about this one and write the node equations for V delta and V0 combinedly. That is V delta minus 20 by 10 plus V delta by 4. For this node, all the branches are completed. Only we have two branches. Now coming to here, V0 by 40 plus V0 by 40 is equal to 0. Here also we have only two branches, so these two are completed. So if you take LCM, 4V delta minus 80 plus 10V delta plus V0 is equal to 0. So 14V delta minus 2V0 is equal to 80. Equation 1. Now apply KVL to this loop, that means this node and this dependent source. So if you apply KVL, so it is plus V delta is equal to, here it is, so this plus and plus are connected in same node, so it is 5V delta plus V0, or you can write, consider this is the closed circuit, so here let it be current in this direction. If current is leaving the positive terminal in KVL, we take minus V delta. Here current is entered positive, so take 5V delta. Here also current is entering at positive, so take positive V0 is equal to 0. So you get same equation. So by solving, 4V delta plus V0 is equal to 0. Equation 2. Solve 1 and 2. You will get the values of V delta is 13.33 volts and V0 is minus 53.33 volts. Next question. Using nodal technique, determine I1 in the given circuit. This is the given circuit. Here we have two nodes. This is one node and this is another node. And this is reference node. Let it be V1. Let it be V2. In between V1 and V2, we have dependent voltage source. So we need to apply super node technique. Before writing the node equations, open the dependent source and write the equation for combinedly V1 and V2. Write node equation for V1 and V2 because it is a super node technique. So this is super node technique. So write the node equation for V1 and V2 combinedly. So write the equation for V1. So here the current is entering to the node. So it is minus 10 plus V1 by 5 plus, you can write the equation for this resistance or you can exclude, because if you write the equation for this resistance, it will cancel. I will show you how it will cancel. That means for this is V1 and V2. V1 minus V2 by 25 plus, coming to this node, so for this branch V2 minus V1 by 25, for this branch V2 by 10, and this current is leaving the node, so it is plus 2 is equal to 0. If you observe here, this is V1 minus V2 and it is V2 minus V1, so both are cancelled. So that's why I am saying you can exclude this resistance or you can write in the equation, but it will cancel. Now take LCM. Minus 100 plus 2v1 plus v2 plus 20 is equal to 0. 2v1 plus v2 is equal to 80. Let it be equation 1. Now apply KVL. KVL for this loop. This is inner loop. Here it is v1 plus v1. Here it is plus v2. Here the current is leaving the positive terminal of v1, so it is minus v1. And here also current is leaving the positive terminal of this dependent source, so it is minus 2i1. Here the current is entered positive terminal, so it is plus v2 is equal to 0. Let it be equation 2. From this, by Ohm's law, what is i1? From this, by Ohm's law, what is i1? i1 is equal to v2 by 10. i1 is equal to v2 by 10. Okay, substitute this i1 value in the equation 2. So you will get minus v1 minus 2 into v2 by 10 plus v2 is equal to 0. So that is 5 times. So minus 5v1 plus 4v2 is equal to 0. Equation 3. Solve 1 and 3. Here v1 and v2 are unknowns, and here v1 and v2 are unknowns. So if you solve 1 and 3, you will get v1 is equal to 24.6153 volts and v2 is equal to 30.7692 volts. Okay, here from this expression we know that i1 is equal to v1 by 10. So i1 is equal to v2 by 10. i1 is equal to v2 by 10. So v2 by 10 is equal to 3.07692 amperes. Okay, this is about the supernode technique. In the next video we will solve problems on the super mesh analysis. Okay, thank you for watching.